Factoring. We can make this really quick. These are the important problems. I have graded so many tests now that I know exactly where people are making mistakes. I'll point some things out along the way. What do we do here when we're factoring? GCF, always. When you're factoring, you're always trying to find a GCF, aren't you? So what is our GCF here? Yeah, good. So our GCF, the number we can undistribute is a 6. That's the biggest number that divides into all those. And it looks like the smallest power of x is x to the 5th. So that's all I can undistribute. Now, if I want to know what's left behind, people do this different ways. One way you can do it is you could play the distribution game where you just ask yourself 6x to the 5th times blank equals 6x to the 7th and fill in the blank, right? If that works for you, that's fine. But a foolproof way of doing it that always works is you could just divide each term by whatever your GCF was. So if we divide each one, remember this technique, 6x to the 5th was our GCF. So we'll just divide each term by 6x to the 5th. 6x to the 7th over 6x to the 5th. Well, the 6's cancel. X to the 7th over x to the 5th is what? Yeah, x to the 2nd, x squared, right? Because if we divide like bases, we subtract exponents, okay? How about this next one? Well, minus 54 over 6, that just reduces to 9, right? And then x to the 6th over x to the 5th is x, yeah. And then how about this last guy over here? This last guy, the x's cancel. Oops. Oh, that's my can. I don't really mean to do that, but get the idea. So those cancel, and we're just left with a number. 24 over 6 is 4. Yeah. Okay, good. And then the last thing we would do is we'd look at this and say, could we go further? So the GCF is done, but what about that trinomial? There's a possibility that we could factor that trinomial, right? We'd end up with x's. If we play the sign game, what would my signs be if they multiply to a positive and add to a negative? They multiply to a positive and add to a negative. Two negatives, right? Are there such numbers that multiply to 4 and add to 9? No. Okay, so we're done. This is prime. So that's as far as we can go is factor out a GCF on that one. And we're done. Okay? All right. How about something like that? What do we do first always? GCF. Okay, is there one? Not in this case. Nothing I can undistribute. So with 4 terms, what's our strategy? Grouping. Okay, here's the mistake that people are making with grouping, I see. Not everybody, but this is the one that seems to come up the most. The one that comes up the most is people aren't getting a plus sign between the groups. So here's what I think you should do when you're going through this process. Write out a template first. This helps a lot in math. If you know what, you can kind of predict what it's going to look like, we'll fill that part out and then put in the specifics. So all we're doing is we're just taking the first 2 terms, go into group 1, just exactly as they're written. So 6x or 6w cubed plus 3w squared, and then we get a negative 10w minus 5. Where people are having some trouble with this is either they're forgetting, it looks like multiplication because they're forgetting to put an operation between the groups, or when there's a negative there, they end up with a minus sign between the groups and that messes them up. It should always be a plus sign between the parentheses that enclose the groups. Okay, you'll see how much easier this is when we do it this way. So what do we do in group 1? Factor out a GCF, which is what? Yeah, it looks like I can take out a 3 and I can take out a w squared. Good. What's left behind? Plus 1. Good, exactly. Because if we were to divide each one of those by our GCF, look what happens. So 3 over 6, or 6 over 3, sorry, is 2. W cubed over w squared is w. And look, that whole thing cancels. But the other mistake people sometimes make is they think it cancels to 0. It doesn't. What does it cancel to? 1, right. What's 7 divided by 7? 1. right? What's, I don't know, like dog divided by dog? Dog divided by dog is 1. Because if you divide something by itself, I'm just picking up some, it's just like, my point is just meaning that, like, regardless of what it is, if I divide something by itself, dog divided by dog is 1, because they cancel, right? So what is 3w squared divided by 3w squared? 1. I just divided something by itself, and so I get 1. Okay, so now, group 2. Again, we already kind of know what the look has to be here, right? The two groups have to look the same. I've got to end up with something out in front. Oh, man. There we go. Something out in front times a leftover. Which part has to be the same? The part in parentheses in grouping, for it to work, those absolutely have to be the same. There's no alternative. So the question is just, could we get a number out front that makes that happen? So what we do is we're going to first look at that term. What would have to be out front for us to get negative 10w? Negative 5. Good. And so we know that one's going to work. Now let's just see if it works with the other term if I distribute. I get negative 5, so it does. All right? So grouping is going to work. We just have to finish because we're not done yet. Some people stopped there too, and they're almost at the finish line, but they stopped one step short. So now how does this turn into an answer, a factored answer? Okay, good, because look, now we've got two different, each group we're adding these two groups. Each group has a common factor that I could undistribute. If I undistribute or factor out the 2w plus 1, what's left behind? 3w squared plus negative 5, which is just 3w squared minus 5. Done. Well, maybe. We could try to go further with this, but can we? We can't, because it looks like it's trying to be a difference of squares, but look at my perfect squares list. 5 is not a perfect square, and 3 is not a perfect square, so we can't go any further. We're done. Okay? All right, good stuff. Okay, let's look at some trinomials. 3 terms now. 3 terms, well, what do we always do first? GCF, good, very important. If I factor out a GCF here, what is my GCF? 6, yeah, look how much easier that makes it. What's left behind if I undistribute a 6? C squared minus 5C plus 6. Okay, good. Now look what that did. See, look what that did. So that gives us, just by factoring out that GCF, we ended up with some constant out front and a basic trinomial, much, much easier to factor. It's not just a good idea with trinomials to factor out the GCF. If you're going to use slip and slide, remember, slip and slide will always fail if you don't factor out the GCF first. Every time it's going to fail. You have to factor out the GCF first in order for it to succeed. Okay, so now what?
Magic numbers.
Magic numbers, exactly. So we're going to set up our template. Take the time, don't rush, take the time to set this up, and we're going to play the sign game. Everybody look at those and tell me what the signs are going to be. Both negative, yeah. They multiply to positive and add to negative. So they're both negative. Now, if you didn't do that, this happened all the time. If people were careless about this and they didn't play the sign game, what I got most of the time was people would say, oh, my magic numbers are -6 and +1, right? Because they add to -5. See the problem with that, though? They don't multiply to +6. If you play the sign game, you avoid those mistakes. All right, so what would the numbers be? 3 and 2. Now that we know the signs are both negative, it's easy for us to know that they're 3 and 2. We don't make that mistake. Okay, and we're done. Okay, how we doing? Good? All right. So here's one where you guys are going to tell me correctly that we want to try to factor out a GCF, right? There is none in this case, though. So what do we have to do if we're stuck with a number in front of a squared? Slip and slide. Good. And one of the things I saw in the test is a lot of people miss problems because they put prime too many times. There aren't very many prime problems on the test, I'll tell you that. I think maybe there's, I don't know, one or two. I mean, not very many though, right? Not many at all. This is one where people a lot of times said, oh, well, okay, there's no GCF, so it's prime. Yes?
Is this a review for a 7 or 6?
7. This is for 7, yeah. 7's the more important. 7's a hard one. 6 is really not that big a deal. Half of that's memorization stuff. More than half of it's memorization stuff. Okay, so you guys walk me through slip and slide, please. So this is some side work, remember? 3a squared. Good, okay. So first step, you were saying, first step. Good, so we slip that number over and multiply by the constant only. So that gives us the basic trinomial, and that's the whole trick here, is now we get a basic trinomial to factor. Okay, and those are easier. So we get A's, play the sign game. Everybody agree, both positive? Multiply to a positive, add to a positive, so both positive. And what would numbers be that multiply to 24 and add to 14? 12 and 2. You guys are getting better at this. The more of these you do, the faster you get at this. 12 and 2. Okay, now in slip and slide, what do we do to our magic numbers? Yeah, we divide by the number that we slipped, which was a 3. Okay, so what's that give us? Okay, this reduces to a 4. Okay, good. And when this fraction is reduced, which it already is, if there's a denominator, the slide part is we slide that up in front and make it a coefficient, right? So this becomes 3a plus 2, and we're done. Now, how could we check this? Because on a test, it'd be a good idea to check. Super easy. Just multiply it out. Distribute the a, distribute the 4, add like terms, and you should get that. If you don't, something's wrong. You better go look closer. Okay? That always works with factoring. You can always multiply stuff out and see if you get what you started with. Okay, so now, binomials. Okay, let's look at our patterns for a second, because there's a couple things going on here that I think are tripping people up. So I prefer, like, if you're done, you don't need to review, that's fine, but then go do some homework. Don't be on your phones. Be productive here, right? Okay, you guys work on Unit 7 stuff. If you're done, if you don't need this, that's fine. Put the phones away. Okay, so patterns for factoring. First of all, let's compare, like, what do I mean by patterns for factoring? I'll get you started. The first one, what are my patterns? There's only 4 patterns for factoring, right? For the binomials. We've got squares and cubes. So we don't go any bigger than that, right? Squares and cubes, and we do sums and differences. We're either adding 2 squares or cubes, or we're subtracting 2 squares or cubes. So this would be squares, and we're adding, so it's a sum of squares. Now, what is this pattern? Hint, this is kind of a tricky one. What is this factoring pattern? A squared plus b squared. It's prime. It doesn't factor. Right, so this one is prime. Okay, what if we did a difference of squares? Do you remember that one? A squared minus b squared factors how? Now, what people a lot of times want to do with this, I'm going to show you the alternative here. Like, what people a lot of times want to do is something like this one. A plus b squared equals a squared plus 2ab plus b squared, right? Okay, that is the opposite of what we're trying to do. I want you to think about what happens when you factor stuff. When you factor stuff, look at all the problems we've started with. What do you notice? Do you see any parentheses in the original problem? No. How about that one? No. How about that one? Okay, no, do you see parentheses in the answer? Yeah, we do, don't we? How come? Because our answer is a product of factors, and because it's a product, we need to have parentheses around the things that are being multiplied, right? So we start with no parentheses, we end up with a bunch of parentheses because we've got factors. Same thing here. Notice we start with no parentheses. Do we get them in our answer? You bet, right? So the sign of something that's factored is we're going to see lots of parentheses because quantities are being multiplied. Same thing there, right? No parentheses, yep, parentheses. So when we look at something like this is going the wrong way, isn't it? We're starting off with a product of two things, a plus b times a plus b. I've got parentheses, and I'm ending up with nothing being multiplied, no parentheses. Get it? That's the wrong pattern. These are the patterns we want. What is a squared minus b squared? There are parentheses. It is a product of some things. Difference of squares pattern. A squared minus b squared factors into, you guys must know this. These are the flashcard things y'all did, right? Okay, so let's review these, because if you don't know these, you're automatically, that drops your grade down to, like, even if you got everything else right, you're probably getting a C, right? Because there's a lot of this stuff on there. You got to know these patterns. So this is the one, a squared minus b squared is the a minus b times a plus b pattern. Remember these? Okay, so there's difference of squares. That's one of them. Sum of squares, no pattern. Now we got to do cubes. A cubed plus b cubed would be our sum of cubes pattern. Starting with no parentheses, we want to build this so it's a product of things with parentheses, right? Same thing for difference of cubes. A cubed minus b cubed. You just got to know them. Got to know them. So does anybody remember, what is the sum of cubes pattern? We're going to get a small factor and a bigger factor. The small factor just has a's and b's, right? So it's just this, and literally it's the same thing you start with no exponents. So it's going to have a plus b, right? The two terms that show up in the small factor are just a and b, and they're connected with the same sign that you start with, right? Remember we said those are always the same. What about in the big factor? There's three terms, the three ways of multiplying a and b. A times a times b, and b times b. There's only three ways of multiplying a's and b's, and that's it, right? What are the signs in between the terms? What's this one going to be? We said when we're doing the cube patterns, the first operation is the same, so it's minus then, right? Because it goes same, opposite, and it always ends with plus. Always ends with plus, right? Same, opposite, plus, okay? So what am I going to get down here with my difference of cubes when I break it up into a product of factors with parentheses? A minus b, same, times a squared, plus, I got to go opposite, a times b plus b squared. Okay, got it? Okay, so we got our patterns. Back to business here. We got our patterns. Which is the pattern that could work for this problem? We'll try to factor out a GCF first, but there isn't one, right? Okay, which pattern could work? I've got 16x squared minus something. Only one pattern would make sense. Which one? That one, right? A squared minus b squared, difference of squares. Because I'm subtracting and I've got an x squared, right? So that's the only one that could work. So let's focus on that one. Okay, so remind me. Difference of squares, a squared minus b squared. I want to factor that, so I want to write that with parentheses. How does that one factor again? A minus b. There you go. Beautiful. Okay, so all we need to do is see if we can write that. What does a squared minus b squared mean? A just means something squared. B means minus something else squared, right? So what would be my b in this case? 9. Okay, so this follows our pattern where b is replaced by 9. What would the a be? What thing could I square to get my first term? Not 8. 4x. That's it, right? That quantity, because I've got to get both a 16 and an x squared, right? So I've got to square 4x. So that is like my A, that whole thing, and this is like my B, and I just follow the pattern, right? So that tells me A minus B would just be 4x minus 9, right? Times my A is a 4x plus B is 9. Done, right? Everybody see that? Those are simple, but you got to know the patterns. If you don't know the patterns, you're lost. Okay, how about that one? 2 terms, so it's a pattern, right? If it factors, maybe it doesn't. There's no GCF. I try that first. What's the only pattern that could work here? Okay, but that looks like that's it. A cubed plus A cubed plus B cubed. Yeah. So that's my pattern that we'll try to match, and either it'll work or it won't, one or the other. We'll try. A cubed plus B cubed. So we got to know the pattern first of all. Hopefully you guys remember this. We just went through it. What is it? A plus B, good. Plus B squared, good. There it is. There's my pattern, right? Once we know the pattern, we just have to see if I could write this as something cubed, and whatever that is, that would be my A, plus something cubed, and that would be my B. Well, now you guys can use the list over here, perfect cubes. 64 would be what cubed? 4. Okay, so my B is going to be replaced by 4 if this works. What about here? 5. I've got to get 125 x cubed, so I have to cube a 5, and I also have to cube a x. There you go. So A would be 5x, quantity 5x, in parentheses, right? Because it's the whole thing. B is 4. Yeah, that's fine. So this gives us then A, which is 5x, plus B, which is 4, okay? Now, what about this one? A squared, well, that's going to be the whole 5x squared. Because A is the quantity 5x, right? It's the whole thing. If I square out 5x, what do I get? Because I've got to square both the 5 and the x. So what do I get? 25x squared, exactly. Can anybody predict what a pretty common mistake is right there? They don't square the number, they just say 5x squared is a pretty common mistake, right? Okay, A times B, well, that's just going to be 5x times 4. What's that? 20x, you bet. And then B squared, that's just 4 squared. What's that going to be? We're done. Okay. Remember, that trinomial, don't mess with it. It's never going to factor. In that pattern, in the cube patterns, whatever you get from that second big trinomial is done. It's always going to be prime. Okay? Give me thumbs. How we doing on this? Okay, good. All right, I feel like we're making some progress here. Okay, this guy, I tell you what, I'm going to skip ahead for just 1 second. We'll come back to that one. Okay, this one, I don't think this one's super hard. You'll agree with me, but it's harder than the previous one. Much harder, because the previous one was almost done for you. What's our process if we're solving an equation? And by the way, this was another common mistake, is not including equal signs in each step. If it's an equation has to have an equal sign, right? So every step that we take is just another version of that equation. What's the first thing we have to do to our equation? Subtract 30. Good, because we want to get it equal to 0, right? So we're going to subtract the 30 over to that side, which gives us the equation w squared minus 7w minus 30. I need that equal sign. What's on the other side? 0, which is the whole point. Get it equal to 0, right? Okay, good. So now what do we do to the left side? Because when I'm solving an equation, I'm trying to find the values of w in this case that make that work? Right now, that'd be difficult to know, if not impossible, right? But what could I do to make this easier? What do I do to the left side? When I'm solving an equation, I set it equal to 0, then I factor it, right? Okay, so I gotta see if I can factor this. So I can make my template, those have to be W's. Let's play the sign game. Take a second, take your time. Don't rush this process and tell me what the signs are gonna be. Negative, positive, aren't they? Right? Okay, how do we know? Because they multiply to a negative, so they're different. They add to a negative, so the negative is big and the positive is smaller, right? Always do the big one first. So what are my numbers? 10 and 3. Okay, so then now this is much easier to deal with because we can use the zero product property. The only way that I can multiply two factors and get 0 is to multiply by 0, right? So what's the value of W that would make that first factor 0? Positive 10. If W is 10, that's going to make this factor 0. I get 0 times something is 0. That works out. How about this one? Yeah, if W is negative 3, I'm going to get 0 times something is 0, right? So it works. So this previous problem is the easiest one on the test. It's already factored, right? Already factored. Don't multiply it out or anything. It's practically done. What's the only way that I could get these two factors to multiply to 0? Well, what value would x have to be to make that one 0 so I could multiply by 0? Negative 3. How about this one? Well, let's find out. I'll just take what's inside and set it equal to 0 and find out. Subtract or add 2, divide by 5, and I get x equals 2/5. Done. Easiest problem on the test. 90% done for you. Okay? All right. Good? Okay, let's maybe look at, how many more do we have? Well, we're getting pretty close. We've only got, let's do the next 3 tomorrow, and then you have the rest of the day to test or do whatever, okay? That make sense? So that'll give you, if we finish this up tomorrow, like, I'm willing to give you guys a day later, like Thursday or Friday to test also. Okay, how about if I've got one small thing I'll do Thursday, and we'll take Friday's test day then too. Sound good for you? Okay.
So